The universe is mostly empty space, but sometimes it sends us a message. On July 1, 2025, astronomers in Chile spotted a faint, fast-moving smudge of light, 3I/Atlas. The 3I means it's only the third interstellar object ever detected passing through our solar system. This was not just another rock, it was a true alien visitor, a traveler from another star. The discovery electrified the scientific community. Interstellar objects are rare and mysterious. Before this, we'd only seen Oumuamua and 2I/Borisov. Now a third, suggesting these cosmic visitors may be more common than we thought. But the excitement quickly turned to alarm. 3I/Atlas was detected late, already deep inside our solar system and heading our way. Our sky surveys missed it until it was nearly on our doorstep, a sobering reminder of our vulnerability. We've mapped and tracked local asteroids for years, but this object follows no familiar path. It's a wild card, an unknown variable in the clockwork of our solar system. Its late detection exposed a terrifying gap in our planetary defense. We were watching for threats from within, but the real danger might come from the outside. Telescopes worldwide scrambled to gather data, racing to calculate its trajectory. Early models suggested a safe pass, but new data painted a darker picture. The orbit was uncertain, the answers unclear. This was no longer just a scientific curiosity. 3I/Atlas was quickly becoming a source of existential dread. The universe had sent us a warning, one we almost missed. Now the world watched and waited, hoping for answers. The question was no longer what is it, but what will it do? For the first time, we faced the possibility that something from the stars could change everything. And we might not be ready. To grasp the threat of 3I/Atlas, you need to know its stats. And they're terrifying. First, its speed, 137,000 miles per hour, far faster than anything orbiting our sun. That velocity means almost no time to react, and a collision would unleash unimaginable energy. Then, its size estimates put the core between half a mile and over 3 miles wide. Even at the low end, it could destroy a city and disrupt the world. At the high end, it's a mass extinction event. But the real nightmare is its trajectory. As an interstellar object, it's not confined to the solar system's flat plane. Its steep, unpredictable path makes modeling its orbit incredibly difficult. Early calculations suggested a safe pass, but new data shrank the margin for error. Outgassing, jets of vapor from its surface, could nudge it unpredictably. Is it being pushed away from us, or toward us? We don't know. The models show a range of outcomes, including a direct hit. We're watching a game of cosmic roulette, and the ball is still spinning. The uncertainty is what keeps astronomers awake at night. Every new observation could tip the odds. The world holds its breath, waiting for the final answer, and time is running out. The warning about 3I/Atlas didn't come from conspiracy theorists. It came from Harvard's top astrophysicists. These are data-driven experts, not alarmists. Their models, using the latest observations, showed that an Earth impact could not be ruled out. When the stakes are global extinction, any non-zero probability is cause for alarm. This isn't a movie plot. The real danger is the uncertainty. The comet's path is sensitive to tiny, unpredictable factors, outgassing, planetary gravity, and more. Harvard's warning wasn't a prediction of doom, but a statistical red flag. Their credibility makes this a global crisis, not just a remote possibility. The numbers have them worried, and they're ethically bound to share that concern. 3I/Atlas exposes a blind spot in our planetary defense. We've focused on local asteroids, but the threat from interstellar space is real, and far less predictable. This is a new class of danger, one we're completely unprepared for. The sky is not as empty as we thought. Our place in the cosmos is more precarious than we ever imagined. 66 million years ago, a 6-mile-wide asteroid ended the reign of the dinosaurs. The impact unleashed energy beyond millions of nuclear bombs, triggering firestorms, tsunamis, and a years-long winter. 3/4 of all species vanished. Now 3I/Atlas echoes that ancient disaster. Its size puts it in the same league as the Chicxulub impactor. An impact would vaporize crust, ignite global wildfires, and block out the sun. If it hit the ocean, mega tsunamis and climate chaos would follow. Photosynthesis would stop, food chains would collapse, and extinction would sweep the planet. Human civilization is even more fragile than the dinosaurs' world. The Harvard warning is clear. This isn't just about a city or a country, it's about the survival of our species. The universe doesn't care who's in charge on Earth. Not all cosmic threats are equal. We track local asteroids for years, but 3I/Atlas is a one-time visitor from another star. Its path is unpredictable. No historical data, just a short arc of observations. Outgassing and measurement errors make its trajectory a moving target. Our defense systems are built for slow, predictable objects, not this. Its composition is a mystery. It could contain exotic materials or unknown chemistry. An impact might introduce foreign elements to our planet, with unpredictable effects. We don't know if our deflection strategies would work, or just shatter it into deadly fragments. The discovery of 3 interstellar objects in less than a decade suggests our solar system is a cosmic shooting gallery. For most of history we were blind to these threats. Now we see how fragile our existence really is. 3I/Atlas isn't just a singular threat, it's a warning about a new, persistent hazard. It's a reminder that we live on a tiny, delicate island in a vast, violent universe. The unknowns are what make it so dangerous. We're only beginning to understand the risks. What can we do about 3I/Atlas? The answer? Almost nothing. Our planetary defense is in its infancy. We've nudged small asteroids, but 3I/Atlas is a different beast. Massive, fast, and unpredictable. Changing its course would require unimaginable energy. A nuclear detonation might work, but getting a bomb there in time is nearly impossible. If we hit it wrong, we could shatter it into a shotgun blast of destruction. Exotic ideas like gravity tractors or lasers need decades of lead time and technology we don't have. Our defenses are built for threats we see coming a century away. For a fast-moving interstellar object, we're just spectators. We can watch it come, but we can't stop it. The hard truth, we're not ready. A threat like 3I/Atlas would test humanity as never before. Would we unite as a species or fracture along old lines? If impact is inevitable, who gets saved? Who decides? The ethical and political dilemmas would be staggering. Some would call for global cooperation, others might turn to panic or extremism. The comet is just a rock, the real test is how we respond. Our survival may depend on our ability to act together. Whether 3I/Atlas hits or misses, its discovery has changed us. We now know the sky is not a peaceful canopy but a dynamic, dangerous place. We must invest in better telescopes and detection systems, finding threats decades, not months in advance. Deflection technology must move from theory to reality. This can't be one nation's project, it must be a global priority. The lesson is humility. We're fragile, but we're also sentient and capable. Unlike the dinosaurs, we can understand the threat. And maybe, one day, stop it. This danger can be a catalyst for growth, pushing us to become wiser and more united. The story of 3I/Atlas is about us, about whether we have the will to secure our future. Looking at the sky is now an act of survival. We must watch with vigilance and determination. The next time a visitor comes, we need to be ready. Our future depends on it.